Alright guys, so we're doing a second calculation in regards electrical load. Electrical load calculation is used to determine the right amount of, say, power or load that is required for a single premises, such as a single dwelling unit. So this question, we're going to use a standard method to determine the service load for a 950 square feet single family dwelling containing the following loads, and that include range at 8 kilowatt 240 volts, electric dryer or a dryer at 450 kilowatt at 240 volts, dishwasher 12 amps at 120 volts, water heater at 4000 watt 240 volts, and finally AC unit and electric unit both operating at 240 volts. AC unit as a measure of 28 amps and electric heating unit at 12.5 kilowatt. Alright, so we're going to be looking in detail in regard to this question, and we're going to take the following steps so that we don't create any error along our way while we're doing this calculation. So first we're going to take in consideration the lighting and receptacle load. Then we're going to look at the fixed appliance load. Then third, we may include the dryer load. And the fourth one, the range load. And our fifth one, which is the AC unit or the heating load. Okay, so the first step in this question will be focused on the lighting and the receptacle load. Lighting and receptacle load is that load which is include the receptacle and the general lighting. Alright, lighting is determined based upon occupancy, and it also may be determined by lighting receptacle or fixture rather itself. Alright, so we are given the occupancy of 950. So 950. Alright, let's say lighting and receptacle. To begin with, so it's 950 square feet times 3 VA per square feet demand. Alright, and that is so it's 950 times 3 VA per square feet, so that gives us 2,850. VA. All right, and the next is a receptacle load, and that is based upon the small appliance and also the laundry appliance. All right, so standard, we must have 2 small appliance, circuits, both at 1500, so that gives you 3000 VA. And the laundry receptacle circuit, all right, that is 1500. All right, so we're just going to add these value up. And that is all right. So now when it comes to the lighting and the receptacle load, we have to apply a demand factor. All right, so based upon lighting and receptacle, the demand factor would have been, for the first 3000 would take 100%. So the first 3000 VA will take 100% of the load. So that will give us 3000. And the remainder, you could have said the second will take at 35%. And the difference would be 4350. So 4350 times 35. So a fraction of that value is 1522.5. Of course, that's VA. All right, so all we got to do is add up this value. So it's 3000 plus 4522.5. All right, so the next step in this question, we'll be focusing on our fixed appliance. The fixed appliance is given in our question, and let us go over the fixed appliance. The fixed appliance include the dryer, the dishwasher, and the water heater. All right, so given in this question, we only have 2 fixed appliance unit. So we have a dishwasher at, that's 12 amps, 120 volts, and water heater at 4,240 volts. All right. So for the rules regarding fixed appliance unit, when we have 4 or more appliances, we will take 75% of that load. In this case, we have less than 4, so we will take 100%. So let's find the value for the dishwasher. That is 1,440 VA. All right. So all we have to do here, just add both values. So the fixed appliance. All right. Fixed appliance load is total to include both our dishwashing load, which is 1,440 plus 4,000 watt for the water heater load. So let's add that together, and both fixed appliance and water heater would have give us 5,440 VA. All right. So next part of this question, we shall look into our dryer load. All right. So the dryer load is 4,500 watt. All right. So 4.5 kilowatt. All right. In translation, 4,500 watt. So now for dryer load, we should take a minimum of 5,000 VA per unit. All right. So every dryer appliance has to take a minimum of 5,000 VA when it comes to this load calculation. All right. So we'll take into consideration the value. All right. So the minimum load for dryer is 5,000 VA. All right. So that is going to be included in our final calculation. So now I want to look at the next load, which is the range. All right. So the range is 8,000 kilowatt. All right. All right. Let's call this our range load. Now let's look at how we're gonna determine the final load requirements for the range. All right. We're going to use table 220.55 of article 220 in regards electric range or heating elements. So we're going to extract that from the table 220.55. All right. So So we go into Article 220 of Table 220.55. All right. So looking at 220.55, remember our radiated load is 80 kilowatt. So we have to look in the column B for this number. All right. So in this column, it gives us a range between 3.5 kilowatt to 8.75 kilowatt. And remember, we have one appliance. Right. The demand factor for this value would be 80% of 8 kilowatt. All right. So we're going to take 80% of that value. So all we got to do is times 8 8,000 times 80%, which is 0.8, right? And that value would be 6.4, right? Kilowatt. So it's 8.8. All right, which is 6,400 watt. Right, and then the next one we're going to focus on is the AC unit or the heating load. So let us examine the AC or the heating load. Remember, when it comes to AC or heating load, we take either of the largest value. All right, so the demand would be based upon the maximum capacity of the load. So we're going to take the highest value, because when it comes to these units, you can only run one at a time. All right, so we're going to take the highest value. In this case, let us determine the AC load. So the AC load, it starts at 28 amps, 240 volts. All right, so let us determine what that is. So that value is 6,720. All right. So let's say the AC unit is 28 by 240. And that works out to be 6,720, right? 6,720. And let us compare as the value of the largest unit that is required for this question. So the AC load is 6,720, and our heating load is 1250 kilowatt. All right, so we're gonna omit the lowest value. So let's take out the AC load. All right, so now we're going to consider the heating load. All right, so we're going to take the summation of the total load, and we are going to apply the rules in regards a service load. All right. All right then, so the total demand now that will equal 1 lighting and receptacle. And 2 fixed appliance and 3 dryer and 4th one is the range. And the 5th one, we're gonna take the E10 load. All right, looking into this, let us write down the value that we get. All right, so the receptacle and the lighting load was worked out to be all right, so we have 4,522.5 VA. The fixed appliance load was 5,440. All right, and then we're gonna take in consideration the minimum for the dryer load, which is 5,000. Remember the demand per dryer, even though the value was less, as it was 4.5 kilowatt. All right, and the range is 6,400 VA, and the E10 load, which was 12,500. All right, so all we got to do here is just add the values, knowing that we already take the demand or apply the demand already from the initial part of the procedure. So now we just add the values. And that works out to be 33,862.5. Right? So now we need to finalize this load. All right, so the load, which is I, would be determined by VA divided by the voltage, which is the supply voltage. All right, the supply voltage in this question is 240 volts. All right, we call this V. Let's call this VS. It is 240 volts. All right, so I is equal to the total VA load, which is 3386.2.5 VA, all divided by 240. All right, so let's finalize this value. So that would be 33,862.5 into the supply voltage, and the value works out to be 141. All right, so the value is 141.9. all right, so that's just about it. The question did ask us to go ahead and find anything more than the service load. All right, so we won't be considering the service at this moment. All right, so we'll be finalize this at 141 amps. All right, so that's just about it. All right, guys, just give us a like and make sure you subscribe to this platform. Thank you.